Bye, Marina.
Well, Marina, good luck at your audition.
Okay,
Shoot.
today we are going to learn the last two tests of series convergence. Okay, and the tests that we are going to learn today, one of them is only useful seldomly. The other one is useful a lot. Okay, it really opens up the doors. So they are very similar tests in the fact that they have very specific restrictions. We're going to start with the most useful one, the ratio test. So write down the ratio test.
Can I drop the just put ratio test?
Sure.
No.
Oh, look, that's what I did.
Oh, okay. I'm just double checking. You don't want to sketch.
Okay.
No.
There are three conditions to the ratio test, and maybe not three conditions, but three different ways this test could go, is maybe a better way to say it. So let's just say we have a series where a sub n is the sequence inside, and we have non-zero terms. Okay. If we take the limit of a sub n plus 1 over a sub n in absolute value, and it's less than 1, then we have a converging series.
How does someone figure this out on their own? They spend a lot of time doing math. That's true. I guess that people need to do it.
People dedicate their careers to finding new things in math, and
That
they
feels
had to
like
get discovered at some point, and that's what happened last year too. Okay?
that feels like
Now, what do you think the next? What do you think number 2? Diverges if?
Oh my god, I should be a math teacher.
So what if it's equal to?
What if it's equal to 1?
It tells us nothing.
It tells us nothing.
That's what I'm talking about.
Okay. If our limit is less than 1, our series converges. If it's greater than 1, our series diverges. And if it equals 1, it's inconclusive. And we have to do
Yes. So you can just get a job trying to find like patterns in math. Like just doing math.
Jackson Hazelhorst is co-authoring a paper on a number.
On a number?
Mm-hmm.
What number? 4?
Like what do you mean a number?
5?
I feel like it'd be more like
Like,
E
you know
or
how,
I.
like, the number E was discovered through
Oh, like a
patterns.
rational number. So they came up with a new number.
I don't think you invent numbers.
You can find
Discover
those.
them.
But there's
You could find
there's
no idea.
patterns that you can find and play around with, and
You can play with them?
he is
It's pretty impressive.
publishing a paper.
You fit it. It's fit it.
What's it about? They were talking about that.
I am not going to remember off the top of my head and tell you correct. Like,
Did you read his papers on it?
What number is
he
it?
hasn't.
I know, but you'd think he'd give it to you first.
Will you let us know when he publishes?
What number is it?
Are we done writing this down?
Yes.
Wait, is it absolute value? Is that why those lines?
It is the absolute value. So if we have any sort of alternating piece, right?
That's smart.
This would tell us if it converges absolutely, right? All of these series that you test with the ratio test will converge absolutely because there's absolute values around it. Does that make sense? Okay. I really like the ratio test when we have a mix of functions mashed together. For example, 2 to the n over n factorial. It's like, we took two things that we could do separately and we mashed them together.
Just need a lot of
Okay? There is literally no other way to test for convergence than the ratio test on this problem. Integral test, not even a thing with a factorial.
I feel like Jackson could do it a different way.
Let's use a number.
It's just like-
Okay, so what we are going to do for the ratio test is we take the limit as n approaches infinity. Inside the absolute value, we're going to take a sub n plus 1 divided by a sub n. Okay? That's probably the last time you'll ever write it as a fraction like that. Okay? Because we're going to have to work with reducing this. So my suggestion would be just right out the gate, write it as a sub n plus 1 times the reciprocal of a sub n. And we're going to have to do some reducing before we can look at the limit. Okay? So let's kind of group things together. Now, I'm writing more down than I think is necessary, but I want you to be able to visualize this. This is the first time we're going through a problem, and the more problems you do, the more maybe steps that you can skip from what I'm doing up here. Okay? So it would be a good idea to group our 2 to the powers together and our factorials together so that we can see what they would reduce to. Okay. I don't know if this is a step that's necessary to write down for you. Maybe it is, maybe it isn't. This is one of those wishy-washy steps. You can either visualize it in your head or you can write it down. This is up to you. Okay? But what happens when we take 2 to the n plus 1 over 2 to the n?
2.
Okay? 2 to the first. N factorial over n plus 1 factorial.
And is that two? Oh, it's two.
That just goes to
To the
0.
Mhm.
We should-
Because if we think about this right here, 2 to the n plus 1 is the same thing as 2 to the n times 2 to the first.
That's so weird.
So the 2 to the n's are going to cancel out. Okay?
It's the same as the
Wait, can we go back over how we like switch the denominators? What did we do for that?
I just did the commutative property and switched these two so that I could have things grouped together and I can simplify. Okay? Are you okay with how I reduced to 2 to the first power? Stop talking to each other. Are you okay with how I reduced to 2 to the first power?
It's what we did over there with the peas.
So what's the limit towards infinity of 1 over n plus 1?
0.
It goes to two.
It's
It's to the first is zero.
No.
It's multiplied by 2.
What's 2 times 0?
Oh, shoot.
Oh.
Yeah, I definitely did not see that.
That's right.
Hey, how does 0 compare to 1?
I'd have to say it's roughly less than.
Okay. So this series converges, absolutely, by the ratio test.
More often than not, we'll convert by the ratio test when it's going to 0. How often will it be like it converges because it's going to 1/2?
Oh, yeah, we'll look at, one. Yeah. We won't look at one, sorry, but,
I feel like more often than not, it's going to 1/2.
well, this could be like n over n plus 1, and it won't always go to 0. It could go to a number less than 1. But you are right. Probably there will be more times where it goes to 0 as opposed to not.
Give a man the crack. No.
Write this down. distraction, that's not gonna be.
Yeah, Richard. I'll just be enjoying my crackers over here.
Hey, there's a sign over there that
Goodness.
says no food or drink allowed.
Why did you want his food or drink?
Okay, so here again, I have like a conglomeration of different types of functions just smashed together.
That actually looks okay.
It does. It looks ugly, and the uglier, the better the ratio test is. Okay.
N squared.
Powers mixed with polynomial mixed with factorial. Those are things to look for the ratio test. Okay. So we know we're taking the limit as n approaches infinity of a sub n a sub n plus 1 divided by a sub n. So I'm just going to go straight for multiplying by the reciprocal because I know I'm going to need that anyway.
Smart. Plus steps, plus rating, plus reciprocity.
Okay, there's a lot going on.
All that was crazy. You're gonna have to like
So I have 3 to the n plus 2 over 3 to the n plus 1. We have n plus 1 squared over n squared. And we have 2 to the n over 2 to the n plus 1.
you can do this all the
What's this limit? N squared over n squared. We look at the coefficients. Okay. So now Zane, we can multiply by 1. It'll be good.
Yeah.
Okay. What are we left with right here? 3.
Yeah, I think so.
What are we left with right here? 1/2. We have an extra 2 in the denominator here. We have an extra 3 in the numerator here. So our limit is 3/2, which is greater than 1. So it diverges by the ratio test.
So if it like equals 1, can we just say it's undeterminable and just move on, or do we have to do other tests?
We have to do a different test.
Is the other test the root test?
The what?
Root test.
Oh, that's the other test that we're talking about today, yes. But that doesn't mean it's going to work for the one that doesn't work for the ratio test.
We have a question.
Yes.
For the ends, like n plus 1 squared over n squared, how does that simplify it?
It doesn't. It's the limit as n goes to infinity. And so if we think about the fraction where the degrees are the same numerator and denominator, we know that the leading coefficient is our limit. So the leading coefficient of 1 over 1 is our limit. Write it down.
Is this one part your
Just write it down. That's all I asked. All I asked is you write it down. Okay.
I love shirt stays.
I still have it.
They hook from your shirt to your socks. Yeah. Shirt stays.
You never
I don't know what those are. That way you don't look like
Do you have a question?
No.
Okay.
Good.
Is the ratio test the way to go here?
No, we can do the.
Don't forget that you should always consider the nth term test first.
Okay.
What's the limit towards infinity of our sequence?
1.
Which is not 0. So this diverges by the nth term test.
And how's
What?
Can you explain real quick? Like, why did one?
Since
Oh.
we're going towards infinity,
Yeah.
our degrees are the same, so we look at the leading
Oh.
coefficient for our horizontal asymptote. All right, ready for the root test?
Yeah.
Root,
Sounds like a horrible thing.
root or root?
It's definitely root.
It's a root.
It's
Two
definitely
O's
rude.
make an ooh sound.
Whoever says it the other way is just wrong.
Wait,
And their
there's-
entire being should be incorrect.
There's another way to say it.
Well, if you grow up in different parts of the country, you
Like
say
Kansas.
it differently. Okay,
Arkansas.
the root test has very similar rules as the ratio test, except
Certain ratio.
we're talking about the nth root as
That's
opposed
not
to the
English.
ratio. I'm gonna do it on
That's
purpose.
not English. Two O's next to each other make an ooh sound. That's English.
Are you writing this down or complaining?
Yes.
Plain.
Write it down.
You can only handle one thing at a time. I'll complain later.
Okay.
Yeah. I like the way
If
root
we're-
ratio sounds.
If we're talking about the nth root, we can only use this if we have something to the nth power for them to be able to cancel out, and then we can have our limit
Wait,
from
do
there.
you say rut? You say rut beer? Or something?
Rut beer?
Like in your daily life?
I used to. I think that's one word that has sort of switched over for
Did
me.
you used to say square rut?
Yes.
No way.
If the limit is greater than 1, it diverges,
Wait a second.
and then people like you make fun of me.
I'm not making fun of you. I just think that's cool.
You're definitely
different.
making fun of me.
You're
Don't
making
even
fun of me.
try.
I'm not making
Caleb
fun
was
of you.
making
Someone needs to
fun.
make fun of Richard constantly. That's cool.
And what do you think the third one is?
Inconclusive.
Where is my? There it is. If the limit equals 1, then the root test is inconclusive.
Hey, I feel like I've seen this once.
Does your husband say root or rut?
My husband says it like you because he grew up in Grand Island.
That's okay.
Rut. Okay, so do you say rough? Like it says
Like,
oh yeah.
like rough.
Yeah. Is it just like
Like
all
if you
like
get
words
nailed
like
down,
that, you
I say rough.
Is somebody's snapgrams going on? Snap people these days.
Are you ready for a couple examples?
Not yet.
Our last test.
Wait.
Do you say,
our
do you
last
say
test.
measure or measure? I know some people from around the
Measure.
US that say measure.
It's actually Measure.
pajamas? Oh,
Soda pop or
what?
soda pop?
Pop.
Pop. Yeah.
But is it club soda or club pop soda?
You said club soda.
Okay.
What
Who needs more time to write it down?
I've never been like, yo, kind of.
First example, write it down.
I didn't write that one.
You can't even make.
Well, if it equals 1, then
Things weird, like you say, it's
Yeah, but I never said it was English. She's speaking English. That's not English. Mine's not English.
You
Mine's
realize
correctly
that
a
people
different
have
one.
accents because of the different parts of the country or world
Yeah, my
in
mom
which
talks
they
weird.
live.
I know. I'm talking about
So-
proper English though.
But people
You
can
go
still
to-
have accents and
Yeah,
speak
Go
proper
to England
No.
and you'll be improper.
Okay.
This is bold.
We're not in
Now,
England.
this
Bold penis.
entire sequence is not being raised to the nth power.
Really?
Oh, we can do the.
It looks like it is. But it's not.
Well, we would have to rewrite it a little bit, right?
I don't.
E squared over n is being raised to the nth power, so we would
Yeah.
want to rewrite it like that.
So it is.
And so it is. It just didn't appear at first. So if we take the limit as n approaches infinity of the nth root of this guy, I'm not going to do the absolute value because this is always going to be positive anyway. I'll really just worry about the absolute value if I need it. Is that okay?
Sure. Alright.
What do
Oh,
you-
that's just part of the. Never mind.
So
Okay, so now we have the limit as n approaches infinity of e squared over n. And as n approaches infinity, what's going to happen to e squared over n?
it's gonna be 0.
Which is less than 1. So this converges.
Convergence root test.
I have a question.
Yes.
Where can you like show the nth root and can't do all the canceling with the n's? Or
If you're going to use the root test, I would like to see the nth root, yes.
Okay, so I can't just see that and be like, oh, it's going to be e squared over n.
Now, would you necessarily need this step right here? Probably not, because you're going to take the limit right here and give me e squared over n.
Sort of freak. Do you say creek or crick?
Oh yeah, that's a thing too. Is it
Write this
crooked
down.
or crooked?
That's a serious question. Did
Is
you
it
grow up
crooked or
saying
crooked?
creek
Because
or
that is
crick?
the thing.
Crooked.
Crick? Is that just like how your parents spoke?
Keep in mind, like, the part of Kansas I grew up in was very close to Oklahoma.
Ah.
So a lot of those, like,
Did most
Yeah.
of the kids?
That's
Did most of the kids say the same thing?
Did anybody live in Oklahoma and go to your high school?
no, because we were about an hour away.
Oh.
But, like, our family business, we delivered into the panhandle of Texas and Oklahoma.
What was their family business?
Ice.
Really?
Yeah.
That's pretty cool.
Like Frozen?
I don't think you're clever for saying that.
You feel all the river.
Okay, so we'll take a time out real quick.
Yeah.
Backstory, Mrs. Holman. So, growing up, my dad's family had a soda fountain, which is like, you know what a soda fountain is?
Yeah.
Like, you go like and have sandwiches, milkshakes, okay? And they delivered milk.
Yeah.
Okay. Back when like milk used to be delivered to porch steps.
In like the glass.
Right.
That's
Like
cool.
I have milk bottles that say Myers milk on them.
That's cool.
Then, as kind of like milk started to be bought in stores, they started an ice business. So like you freeze like, frozen water into bags, right? That you would buy like at the grocery store or convenience stores. So growing up, I would work in the ice plant, either stacking ice onto pallets so that they could be put on trucks and go out on route, or I'd go out on route and like throw the ice bags to the driver to put in the cabinets. And then eventually I like worked in the office doing the books, but that's what I those were my summer jobs.
That's cool.
Wait, can you say milk again?
I don't get it.
I don't know.
The more you know.
Okay, we have a sequence raised to the nth power, which is exactly what we need to use the root test. So we have the nth root of blah 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 to the nth power.
Hey, let's cancel out.
What's our limit?
Rehab.
Times. Let's go. Greater than 1 diverges root.
I have a question.
Yes, Benjamin.
Could you use the nth term test for
Not well. You could if you wanted to take the limit using L'Hopital's rule, using the e to the natural log of the limit.
Well, wouldn't that just be, that would be 3/2 to infinity, so that would be that. That would diverge because it would go towards infinity.
Yeah, that would probably be true. Yeah.
Third page.
Right.
Right.
Yeah, but that's,
Right.
that's 3/2.
Or a 1 to the infinity.
That's
So if
3/2
this
to the
were-
infinity.
If this were 2n plus 4 over 2n, then this really would be your only one. Yeah. Okay.
Good?
Getting abs today.
Not my final answer.
Are they gonna name?
That's my final answer.
Are they gonna name Jackson's number Hazel versus Constant?
Yes.
So you're in agreement that you see the number e up here. Ish. You don't actually see the number e.
Oh,
I don't
That's
see.
right there.
I don't see it.
That's not the number e. The limit as
Oh,
n
the
goes to
limit. No,
infinity
you're right.
of that guy
Oh, yeah.
That's what it is.
inside is e, but that is not e. Okay?
It's indeterminate because
Now, if we were to use the root test, because I see something is raised to the nth power, sweet, I'm going to put it in the root test. What happens?
inconclusive.
Our limit is 1, and it tells us nothing.
if you do the nth term test, though. Oh, you get 1 to the power of infinity. I just put that in.
You get E.
But if we do the nth term test, which is what you all were seeing, just not making that connection. If we do the nth term test and take the limit of our sequence, the limit of our sequence is the number e, which is not 0.
How is it E?
That's like the actual
Because you
definition.
take e to the natural log and move stuff around.
The definition of E is limit of 1 plus 1 over n to the n.
Yeah, so that's what we did when we took e to the natural log of the limit.
I think it's cheating that we actually
That's
And
actually
then-
the number E to discover what the number E is.
Yeah, we talked about it on more than one occasion.
Oh yeah, that is.
That's just cheating.
That is.
in
But you
this
don't
year.
have to use the natural
Yeah, like we did this right here.
I don't remember this whatsoever. The world is happening. Oh my goodness.
The smile things off at this point.
Alright, I'll just take your word for it.
Okay. This is 1 to the infinity,
Literally just did the whole thing.
which means we have to use L'Hopital's rule. But it's in exponential form. So we take e to the natural log of the limit so that we can use our
Oh.
logarithmic properties in order to be able to use L'Hopital's rule. When we use L'Hopital's rule,
Oh, we
our
did.
limit is 1, so we get e to the 1.
I'm there.
Okay.
You don't have to write that down. You just know.
But I'm telling you from now on, you can just say, hey, this is e, because we've done this enough times.
As long as it's 1 plus 1 over n.
Mm-hmm.
What if there's 1 minus whatever?
Then that's like, then you have to do.
Yeah, do that.
Now,
Crazy.
Yeah. I used to have a thing where every time I said math, I said math instead. That was the time.
Have the rest of us.
technically, there would be 2 different ways you could approach this problem:
Symmetric?
geometric or
Root test.
root test.
Let's do
Okay.
geometric.
So, geometric would require no work. We
Correct.
know that the absolute value of R is less than 1.
Yep.
And so we know that it converges by the geometric one.
But is that the fun?
Okay.
Why do
Sick.
you need the like
Moving on.
parameter for the 0 is the absolute value? Because it's on like no matter what, it's above 0, isn't it?
Oh, yeah, that's true.
Unless it is
That's
0.
Unless it's 0, so that's why
Exactly,
they have it.
yeah.
Okay.
Or if this didn't pop out to you as geometric and you see, wow, I see the nth power. If you wanted
Hey, we did an example.
okay, then
Cancel.
the ends cancel and what's your limit? The absolute value of negative 1/2, which is 1/2. It's less than 1, so it converges.
Yep.
By the root test.
Sure does.
So which came first, the geometric or the root test?
I would think that the geometric test did, because it's a special type of sequence, and I think that they were able to expand. That's just me taking a guess.
Alright, perfect.
All right.
So, welcome to pool.
What is the first thing you should always consider when you have a series?
Friendliness. And
Okay. What else do we have?
geometric. P-series.
Over here, I heard
Geometric.
geometric.
Integral.
We have the integral test.
Telescoping.
We have telescoping.
We have DCT. LCT.
AST.
AST. Root
Ratio.
ratio.
Right.
Rut ratio.
That was very good.
It's a lot of tests.
All the tests for one test.
The one quiz.
Okay. Now, lucky for you, I have built in 2 review days.
Thank you.
I don't want to quiz on Monday, but that's not really why I did it. But we need to take some time to really. I don't want this quiz on a Monday. There was not a lot I could do about this one with the snow buddy. Okay? I wouldn't mind it. I'm not gonna lie. So what I want you to do tonight is focus on the ratio and the reach tests. Tomorrow, I'm going to give you a flow chart of here are all of these tests and when we can use them and what they say. And we'll spend some time like, okay, here's a bunch of different kinds of series.
Hey Siri.
Let's talk about which tests are best for which one. Okay? We're out here at 11:35.
Yeah, that's
Kind
weird.
of an awkward amount of time.
It is an awkward amount of time. Okay.
Let's ask Siri about the random things.
Hey Siri, tell me a joke.